Hi, hello, my name is Kiran Kumar. I am your physics lecturer. Today topic is speed of the transfer wave in a stretched string. Welcome to my channel, Nature of Physics and Art. See, what is transfer wave? So, the particles of the medium which are vibrating perpendicular to the direction of propagation of the wave is called transfer wave. This is the direction of propagation of the wave velocity. Okay, here the particles which are vibrating perpendicular to the direction of propagation of the wave. A best example for the transfer wave is stretched string, in which crest and troughs will be formed. This is the crest and this is the trough will be formed in a stretched string. So here transfer waves will be formed in a stretched string and also on the surface of the water. So this is a definition of the transfer wave only. Okay, see, considering a stretched string, this is the stretched string, and here due to vertical jerk, here the wave pulse is created, and this wave pulse moving with a velocity v, from left side to right side in a stretched string. See, for derivation purpose we are considering a circle, that is arc of the stretched string, that is pulse of the stretched string here. So that arc is taken as element dl. Okay, so this is the dl element, that is like a arc of the wave pulse in a stretched string. See, for this, here for two edges, two tensions are acting. This is T1 tension and that is T2 tension, and here try to understand, it is making an angle theta at the center O, and R is the radius of the circle. So the element making an angle theta plus theta, that is 2 theta. Okay, so this tension also making an angle theta, here also making an angle theta, opposite angles are same. Then we can take here tension is resolved into two components. First one is, this is T cos theta, and this vertically downward direction, this is taken as T sin theta, here T sin theta, here also T cos theta, and this is T sin theta. Try to understand. Here T cos theta both will be get cancelled, both are equal in magnitude and opposite in direction. T sin theta is add up, so finally downward direction here acting, that is 2t sin theta. So what is acting downward direction here? 2t sin theta is acting. So 2t sin theta. Try to understand step by step. Now here this 2t sin theta is taken as 1 minute. This 2t sin theta is taken as radial restoring force. So then Fr, which is equal to 2t sin theta for small angles, sin theta is approximately equal to the theta. Okay, then we can write here Tr, which is equal to 2 into theta. Rearranging the equation, Tr which is equal to, okay, T into 2 theta. From the arc, that is from element dl, we can write sin 2 theta, which is equal to dl divided by r. So here also we can write for small angles, sin 2 theta is approximately equal to 2 theta. Okay, then here 2 theta value we got dl divided by r. This value is replacing in the above equation, that is a radial restoring force. Okay, that is Fr. What is that here? Fr. This is Fr, sorry. So Fr, which is equal to, that is T into 2 theta, that is 2 theta value we got dl divided by r is taken as equation number 1. And here dl is the element length and corresponding mass is dm. So we can consider here linear mass density, that I will continue. Please copy this. Here we got the relation, that is radial restoring force Fr is equal T into dl divided by r. See now, dl is the element length. Next one is, okay, that is mu, which is equal to dm divided by dl. That is mu is the linear mass density, which is equal to mass of the element divided by element length. Okay, see, from this equation we can write dm, which is equal to mu into dl, and here this is the element length on the stretched string, which is moving with a velocity v at an arc in a circle. This is the arc, this is the circle. So it has the centripetal force. It has what here? Centripetal force. See now, that centripetal force F C, which is equal to delta m, or we can write dm, okay, r square, sorry, dm v square divided by r. Centripetal force, that is simple formula is mv square by r, but element mass is dm considering. Okay, v is the velocity of the wave and r is the radius. This is equation number 2. This is taken as equation number 2. Now from equation 1 and 2 we can write here, that is Fc, which is equal to Fr, centripetal force, which is equal to taken as a radial restoring force. From this equation, delta m v square divided by r, which is equal to T into delta L divided by R. Okay, try to understand. Just a second. See, here dm, which is equal to, that is mu into dl, replacing here this value. So mu into dl divided by r into v square, which is equal to T into dl divided by r cancelled, dl get cancelled, then v square is equal T by mu and v is equal root over T by mu. This is equation number 3. Equation 3 represents the speed of the transfer wave in a stretched string. Please copy this. Now one example problem. See here. A string of length L is fixed at both ends and its linear density mu. If the string is oscillating in second harmonic, then the ratio of magnitude of maximum velocity of particle and the magnitude of maximum acceleration is. See here the ratio asking, that is maximum velocity divided by maximum acceleration is equal to question mark. See now, maximum velocity is a omega, maximum acceleration is a omega square. Magnitude asking. See, then a omega, okay, this is get cancelled. Then 1 divided by omega. So we can write here omega value is 2 pi into mu, and here 1 by 2 pi mu is equal to v by lambda. So here mu is equal to v by lambda, velocity by wavelength. So next one, that is here rearranging the equation, lambda divided by 2 pi into velocity is v. Okay, so here v, which is equal to root over t by mu. Here v is the velocity of the transfer waves in a stretched string. Then the corresponding value, which is equal to lambda divided by 2 pi. Okay, then velocity is t divided by mu. Then here lambda divided by 2 pi root over mu divided by t. Then here lambda is equal to L for the second harmonic, that is given in the question. Okay, see, then here L divided by 2 pi root over answer for the given question. Please copy this. Second example problem. Listen carefully. A 100 sinusoidal wave is traveling in the positive x direction along string in a linear mass density of 3.5 into 10 to the power of minus 3 kg per meter and tension of 35 Newton at t is equal 0. The position x is equal 0 has 0 displacement and slope of the string is pi by 20. Then select the wrong alternative. First option given, velocity of the wave is 100 meter per second, and second option given, angular frequency is 200 pi radian per second, and third option given, amplitude of the wave is 0.025 meter, and fourth option is propagation constant is 4 pi per meter. See, these are the given values here according to the options we are discussing here, that is velocity of the transfer wave root over t by mu. So then here tension is equal to 35 given, and mu value is that is 3.5 into 10 to the power of minus 3. Then velocity we will get 100 meter per second. And next continuation here, lambda is the wavelength which is equal to v divided by frequency mu. Then velocity is we got 100 divided by frequency also given 100, both get cancelled here. Lambda value is 1 meter. And next one continuation here, propagation constant is k. So then here k, which is equal to 2 pi by lambda. So here k, which is equal to 2 pi per meter, because of lambda is equal to 1. This option is wrong, but we have to do remaining also. Then continuation here, first we got velocity, second we got wavelength, and third we got here propagation constant. And we can discuss the, so how many options are completed here. Velocity we got, okay. Angular frequency we have to discuss, omega value. Amplitude we have to discuss. Fourth option we got, that is wrong. So here angular velocity omega is equal to, we have to find, see here v is equal to omega by k, and omega is equal to v into k. So omega value, velocity is 100, okay, k value 2 pi. See, that's why omega is equal to 200 pi, that is a radian per second. Okay, so here second option correct only we got, that is angular frequency 200 radian, 200 pi radian per second. And next one is amplitude. A is equal to question mark. For this we know velocity of the particle, which is equal to the velocity of the wave into slope. See here the condition is given, t is equal 0, x is equal 0, that is a mean position at which velocity is maximum. That's why we can write, okay, vp maximum, which is equal to a omega. So from this equation, a omega, which is equal to velocity of the wave. So this is velocity of the wave, that is the value we got here, 100 meter per second, that is 100 velocity v of the wave into slope value is pi by 20. Okay, then here a is equal to 100 into pi divided by 20 divided by omega value is 200 pi get cancelled, two zeros are get cancelled, then the value is here 1 divided by, that is 40. So the amplitude answer is 0.025, okay, meter. This is also correct. Please copy this and thank you.